Hi guys, I'm going to do another problem, a couple more problems from section 7.1, assessment B. The first one is number 5, which is three parts. I'm going to do part A and B. Part C is actually very similar to A, except it's going to be a negative number. So on part A, we have 28. This is number 5, part A, 28.32 or 28 and 3200th. So they wants us to rewrite this as a fraction and, of course, reduce the fraction if possible. So this is a decimal point, terminating decimal. So they're asking us to change the terminating decimal to fraction. So the first thing you remember, of course, we told you the number of decimal places tells you what power of 10 you need to divide by to get this number. So you kind of ignore the decimal point. You just write your number. And then, of course, you divide. In this case, since we have two decimal places, that will be 10 to the second power, which is the same as 100. So if this was, let's say, 3 decimal places here, you would have 1,000 here, divided by 3, because that would be 10 cubed, and so on, okay? Now you're just going to reduce that fraction. I went ahead and found it for you. GCD for these two numbers on top and the bottom, of course, is 4. So now all we have to do is take the top and the bottom and divide both by 4, okay? So if you reduce them by 4, that should give you the fraction 708 over 25. Okay, so that will be the most reduced form of this fraction, which is, of course, the representation of this terminating decimal. Okay, that's part A. Let me do part B also. And again, part C is very similar to part B, so you don't have to worry about, so you can try to do it yourself, but it's just a negative number, but it's the same idea. So this was part A. Let me do part B for you. Okay, so the same question, except this time the terminating decimal is 34 actually. 1736. 1736, okay? So they want us to do the same thing. So once again, we're going to go ahead and rewrite this as 341,736. Now, remember we ignored the decimal place, but now we're going to see how many decimal places we have. 1, 2, 3, 4, which is going to be divided by 10 to the 4th power, which of course is 10,000. So that's how, again, you convert from a terminating decimal to fraction. Now, this can be reduced. This time, the GCD, actually, the greatest common factor of these two numbers is 4. So as you reduce both by, this one is 8, actually, their GCD is 8. So if you reduce them both by 8, the fraction will reduce to 42,717 divided by 1250. So that will be the most reduced form of this fraction, which again represents this terminating decimal. Okay, so you can do part C very similar to part A, except it will just be negative. Let me see if I can also do the number 8 also. There was a question about number 8. And the number 8, the answer seems to be long, but it's actually a very simple question. So I'll just kind of let you fill in the blanks. So number 8, the question says, let me read the question. It says, what whole numbers of minutes, which of course minutes being less than 60, because every 60 minutes make 1 hour, could be expressed as terminating decimal parts of an hour. So they want to know what whole numbers of minutes. In other words, is it 5 minutes or 15 minutes or 20 minutes? Which of these are going to be basically expressed as a terminating decimal parts of an hour? So the first observation, if it's going to be part of an hour, of course you have to compare to in minutes. So that will be 1 hour is 60 minutes. So the question is, what number should go up here? What are the possibilities of a whole number of minutes that if you divide it by 60, this fraction would represent a terminating decimal. So if you remember a couple of last videos, again, before we told you that if you have a fraction and if the denominator has only factors, prime factors of 2 and 5, those are the only fractions that can be always represented by terminating decimal. So in this case, we know 60, of course, if you write its prime factorization, I believe is 2 to the 2 squared basically times 3 and then times 5, right? Because that's 4 times 12 times 5, which is 60. So if you notice, of course, we have 2 is square, we have 5. So these factors are okay as far as being terminating this decimal. But of course, the 3 is the problem. So as long as that 3 goes canceled, then of course, whatever fraction you left with can be represented as terminating decimal, okay? So now you have to basically list all those numbers that are divisible by 3. In other words, numbers that have a factor of 3 in them or themselves are 3. So the possibilities for, I'm just going to put a question mark here. So this will be your answer. That's why it's a long answer, but it's going to be all basically except up to less than 60. Because remember, the maximum number of minutes is 60. That's 1 hour. So you're going to list, for example, starting with, of course, 0 itself. That will be obviously terminating. But then the first one would be 3. So 3 minutes will be your first answer. But then you start multiplying by multiples of 3. So 2 times 3 becomes 6. That's the next possibility. 3 times 3, 9. 4 times 3, 12. So you're going to do that. You're going to multiply all divisible divisor of 3 until you get to 57. Now why stop at 57? Because that's the last number that is divisible by 3 and of course happen to be less than 60. Okay, so those will be your basically answer. But this is, of course, will go all the way to 57. But that should give you all the whole part of minutes that can be represented the terminating decimal. Okay, guys, thanks.